Hello everyone. So this is our group project for artificial intelligence course. We have developed a Wordle systems that is both playable interface and have full AI engine capable of solving and analyze the game. As you see on the screen, we have all the instruction for running the front end and back end that is already included in the README file. So you can follow those to set up the environment. After you set up the virtual environment and running the backend server, we simply open a new terminal tab to start the front end. And once both sides are running, we can access the application through the provided local links. This will bring us to the main interface of our Wordle app. So the apps have two modes. We have the human modes and the AI engine mode. In the human mode, the layout is divided into three main sections. On the left, we can see you switch between human and agent. In the center, you can have the interactive Wordle board. On the right, we have an analyst panel which acts as an AI assistant that help player by showing viable candidate words and recommending optimal guesses. This analyze system uses our strongest solver from the reports hill climbing with entropy, which achieve about 99.8% win rate. And below the board, we see the guest progress panel, which continuously track how many possible words remain at each steps. Everything updates in real time. So let's get maybe started and we can have a demonstration. After we can have a look at the analyst, we can hide or either we can show them. So yeah, after we get used to our format, we use the word apple first for our guess. We can see that the system immediately returns the appropriate color-coded feedback. Yellow letter means the character is in the hidden word, but it is in the wrong position. Gray letters indicate character is not found in the target word. And the other case is green, which is not appear here, means that the letter is in their correct position. So based on this feedback, the users continue guessing. The guess progress show how many candidates words remained. So the player has up to 6 attempts. And if the users fail after 6 guesses, the game will reveal the answers. So here we will try to lose after a lot of apples. And we see, for example, here is the screen. We have the statistics, the win rate, the number of game played, average guesses, and the number of loss. So we see here our correct word is lot. So yeah, we can just press the reset button and reset the game to play a new game guessing a new word. So although Wordle itself is simple, our system enhances the game by adding an optional AI analyst on the right. So by default, you can hide it and you have a hardcore mode. But if the player wants help, as you can see, they can toggle the analyst panel to see suggestion and remaining possibility. And when the player input the guess, the analyst recompute the remaining candidates in real times. As you can see right here, it computes again and recommend the optimal next word. And for example, after several reduction, the system can narrow down the candidate set just down to one word, which is the correct answer, as you can see here, which is Kiyu. Yeah, this is effectively showing the output of our solver, which is the hill climbing entropy, the strongest in our, reports. So yeah, toggles hide or show for your own likings. If you like hard mode, just hide it away. And next we'll switch to the second mode. AI engine mode. This has two major functionality. The first one is single word simulation. We can choose a random target word and then select one of our algorithms to solve it. So our project implement 9 algorithms, and the guess progress is still in the same place. It still show how many words remain can be the candidate for the correct word. Here you can see the 9 algorithm, the CSV-based brute force, and the other local search family. Hill climbing, stochastic hill climbing, simulated annealing, and genetic algorithm. Each algorithm can run on one of two heuristic function, a custom heuristic developed by our team, and another one, a more well-known entropy heuristic popularized by 3 Blue 1 Brown, a fairly famous YouTube channel and website that talks about math and artificial intelligence and other computational related things. So, for example, I choose a CSP and a word, and you can see the solver running step by step until it finds the correct exact answer. As you can see here is fault. We can also switch to hill climbing or any other algorithm to observe different solving behavior. And most algorithm is quite fast and you can solve it in only a few steps. As you can see here, scale only go through guess number 4 to have the correct answer. And you can see here another case with stochastic hill climbing entropy. A little bit ups and downs, but we still got our hard, weird target words. So enough with the single guess simulation. We go to our large scale statistic. That is a statistical testing mode. Instead of just solving one word, we can select a data set of 100, 200, or even the full data sets of 15,000 words. The system will run and select the algorithm on the chosen number of test words, and they will report the following: how many guesses each word required, how many words the algorithm failed to solve within 6 tries, the overall distribution of the results, real-time progress of how many test cases have been complete, and you have the ability to also stop the process midway if it takes too long to process. You can see here, you can see the progress 25, 26, 27% jumping really fast. And you can see we can stop whenever we want if we don't have the time or we just too impatient. And if you are too indecisive, you can just randomly choose. You can see here the genetic algorithm is significantly slower, sometimes taking around 0.1 second per word, which become very expensive at a larger scale. You can see just at 1300 words it takes kind of long. So we just kind of play through all of the algorithm and see which one will achieve a fast speed. So not this. Let's try hill climbing. Oh, we can see that hill climbing is really fast. Just about a few dozens of milliseconds. And yeah, let's just wait this out and see the full test so that you can get a better context of the whole picture that we're implementing. We're almost done already. And another thing to note that the statistic mode is completely independent with the individual single words simulation on the left. So while you wait, you can play these two things individually. So you just have to wait here. You can just run a stochastic hill climbing over here, try some words, and the moments of, you know, the hill climbing just running. And over here, you just try all the other algorithm. So yeah, we have completed the demonstration of our Wordle project, and the system supports both human gameplay and full AI engines with multiple heuristic-based solver, along with detailed statistical evaluation tools. Thanks for watching and have fun solving Wordles.